So in work we're going to be presenting at the IMW, led by Bonel Patino Escobar, who's a postdoc in my lab. Bonel is going to be presenting work on our efforts in the lab to understand what are the proteins present on the surface of myeloma cells, because we know that now with immunotherapies coming to the fore in the treatment of myeloma, these essentially are really focused on targeting surface proteins. And so the leading ones we know about, say CD38, BCMA, SLAMF7, these are all known. But the question is, are there other ones out there that could serve as other new targets? Because we know the current therapies against these known targets still are not cured. And so we think that there's still a demand for new targets and new therapies against new targets. And so, to do this in our lab, we applied cell surface proteomics, where essentially we can isolate all the surface proteins from tumor cells and then apply mass spectrometry to them, quantify them, and then use other bioinformatic approaches to find targets that appear most specific for myeloma plasma cells. So again, our goal is to find markers that are only on plasma cells and very either absent or very lowly expressed on other normal cells, because that way we don't have toxicities when we attack this target. And so through this work, one of the most promising targets we found is called CCR10. This is a chemokine receptor. We found it to be highly expressed on plasma cells, expressed at low levels on some T cells based on transcriptional profiling, but that's about it. Interestingly, it appeared to be highest on non-plasma cells on T regulatory cells, where theoretically we could eliminate plasma cells and these regulatory T cells that lead to immune suppression and potential resistance to current immunotherapies. Maybe we could get rid of plasma cells and T regs at the same time. And so what we showed is that profiling a bunch of primary samples, cell lines, CCR10 appears to be uniformly expressed on the myeloma specimens that we looked at. We found it to be present on T regs in myeloma patient bone marrow aspirates, and we even developed an initial chimeric antigen receptor T cell to target CCR10 by using its natural ligand CCL27. So we have a proof of concept of this immunotherapy. And so that's really the point now, is we're trying to work to optimize that cellular therapy and trying to make a proof of principle immunotherapeutic that, again, a long way to go, but maybe one day could benefit patients as a new therapeutic option.